Hello, this is number 81, Format String Attack Detection and Response. If you have any questions or comments, please feel free to contact us through MS Teams or my email. Number 81's lab overview is that we can detect and respond to format string attacks. The lab environment is consisted of attack server and victim server. The attack server is Kali Linux and the victim server is CentOS 5.5. The victim server's version is 5.5, so we can note that the later versions like 6.0 have modified this vulnerability so strong to format string attack. The format string attack exploits a vulnerability in the printf function but uses format string. Typically, the format used to accept input from the user or output results. To obtain the root to share by writing the address of the shell code to the location of the return. This lab aims to change the value of the variable path to 144 as a practice to see if the variable value defined in the program can be changed to a desired value when a vulnerable function is used. The symptom is known. The attack method, detection, and response method are shown in the following slides by your lab tasks and solutions. The lab task is that attacker seizes, seek format string vulnerability and takeovers its shadow file. Analyze seek format string.c file and then please remove the vulnerability. For the lab, you might connect to CyberAegis and log in with your account. The lab environment is consisted of attack server and victim server. The attack server is Kali Linux and the victim server is CentOS 5.5. The login account is here. The first step of lab is initiated by attacker in attacker server. You, as an attacker, connect to the victim server using SSH with account test. Then go to the seek directory. Check the vulnerable code of the source file FormatString.c. For this, we first look at the secure or safe code in the next slide. This is the secure original code. The code works like this. If you enter the root password, root123, you will be given a root share. If you enter a different password, it prints wrong password and no root share is given. Now, look at the format string behavior. 1. Format string with argument A. You failed. 1. Format string with argument B. You also failed. However, 1 format string with argument root123, you get the root to share. This is normal behavior. Now, let's back to step 3. Check the vulnerable code of the source file FormatString.c. From the original code smprintf, the format string %s is omitted, so vulnerabilities exist. We also note that even though the correct password root123 is not typed, if the value of the variable path is 144, root to share is given. Now, again, let's run format string with argument A. Note that the address of the variable path is bffec00. For each test, the address of the variable can be changed. Format string with argument ABCD and etc. as variable path address as BF FFEBD0. The same argument is length, the format string runs, the variable path address is same. Now, we debug format string with gdb format string command. In gdb prompt, we type disassemble main. You can see that the address of if path equals 144 is the address. Here, 90 in hexadecimal equals 144 in decimal. In the previous slides, we finished the solution step 4. Before proceeding to step 5, we check 4 points. One is %n format specifier in C programming language, and one is call stack sequence, and the other is Python usage, and finally printf usage. What is the use of the %n specifier? Nothing printed. The argument must be a pointer to assign the int, where the number of characters written so far is stored. In this example, before %n specifier, 5 characters B, L, A, H, and space are written, so 5 is stored into var. Call stack sequence is a stack data structure that stores information about the active subroutines of a computer program. In this lab, we assume that you are familiar with call stack concept. You can study call stack with yourself using Wiki call stack or YouTube call stack clips. If you have any comments or questions, please let us know. Now, let's check Python print. Here, \x means hexadecimal notation. So, this command prints out these characters. Now, here is printf function. The first printf format string has 3 format specifier, but only 2 variables A and B are given. However, the output has 3 values, 10, 20, and 0. The second printf format string has 4 format specifier and also only has 2 variables. The output has 4 values. These green values are popped from stack, although they have no corresponding variables. This shows that we can see the stack contents using the difference between the number of specifiers and variables. Now, find the moment the value of a variable path changes by increasing %08x. First, when you execute FormatString command with this argument, argc and argv are filled. When main function runs, main's parameter, local variables, path, and buff are allocated in main's stack frame. Then, when sprintf runs, sprintf's stack frame generated. In other words, sprintf's parameters, argv1, size of buff, and buff are put in the reverse order of the definition. We note that there's a dummy area register between main's stack frame and smprintf's stack frame. Now, smprintf works. First, argv1's first part, d0 eb ff bf, written to buff 0, 1, 2, 3. Here, D0EBFF is given, since we know that the variable path address is BFFEBD0 for the format string with the size of argument. Then 9%08x written, and note that there's no argument given explicitly in the smprintf function, only popped from stack. Next, %n is operated. The number of characters written so far. In this case, 76 is entered to the popped location. 76 is equals 4 bytes plus 9 pieces of 8 bytes. This time, the popped location is the pointer of integer, so 4 bytes, the content of buf 0, 1 to 3. That is D0EBFFBF. And this is the address of variable path. Finally, we found that after the 9%08x, the %n corresponds to the path address. In step 6, attack so that the value of the path variable is 144. And note that the command input window to execute as root privilege. Type command, FormatString, and etc. Here, we still use 9 pops, but the 9th pop uses %76x, not %08x. This is because 76 makes 144. The value of the variable path was changed to 144, and a prompt to execute the command with root privilege is appeared. Note, %76x in yellow rectangle in the middle of the command. Now, as a root, you can copy shadow file and change the mode that everybody can read. Then, at attacker terminal, you take over shadow file. Attacker can copy and view the shadow file. Now, defense. Correct the vulnerable part. This is a secure code, and this is also secure code. smprintf with 4 arguments writes almost both size bytes, including the terminating null byte to buffer. strncpy stores origin to dest as much as n. They are now vulnerable to FormatString attacks. The defense method against the FormatString attack are here. You can use any method. Rebuild the FormatString or enable ASLR. Check out the attack does not happen with the same account test. This is the attack file seen when we defense using FormatString revealed. And this is the attack file seen when we defense using ASLR enabling. Finally, you check your lab. Thank you for your listening.